In this lab, we will be creating and using two reagents that are used for analyzing different types of organic compounds. Both of these reagents are solutions that contain something called a coordination complex, but that's a fairly advanced idea that we're not going to get into in this class. What we want to focus on is the fact that these are both solutions. We often do chemistry in a liquid solution with certain liquids, solids, or gases dissolved in that solution that are able to react to form interesting products. We use liquid solutions because we're able to do liquids at a pretty reasonable temperature without a lot of pressure, but with still a fair amount of speed to the reaction. Paints, soaps, and even soda and the flavorings for candy are all chemicals that are made in a solution. We'll produce these solutions and then see what they look like in action. We'll make an excess of Benedict's reagent for use in biology, but Toland's reagent needs to be disposed of right away because it will decompose into a contact explosive. One important factor to note is that in chemistry, we often have qualitative tests and quantitative tests. In this lab, we're going to be looking at a qualitative test, and the difference between those is that in a qualitative test, we're just concerned if something is or isn't. For example, the sugars we're going to test in this lab, one of them will have a reducing component and the other will not. That's all we're testing for. We're not testing how reductive is it, we're just testing whether it is or isn't. A quantitative lab would put some numbers and some calculations to it in order to determine the amount that something is. For the discussion in this lab, I want you to define the following terms: solution, solvent, precipitate, and the difference between reactants and reagents. These should all go in the theory section. Then, I want you to write up a few paragraphs explaining why chemistry is often done in solutions. What does it mean when something dissolves? What kind of things dissolve in water? I'll have sources for you in the comments below. We will start by making the Benedict's reagent, and while you're waiting for everything to dissolve for that, you can prepare the Toland's reagent. You'll need boiling water for both tests, so once your reagents are ready, you'll place a 150 milliliter beaker with some tap water onto the hot plate and heat it up to at least 75 degrees Celsius. For Benedict's reagent, you'll need sodium carbonate anhydrous. That means it doesn't have any water in it. You'll need sodium citrate. You'll need copper sulfate, a 50 milliliter graduated cylinder, a 250 milliliter beaker, 2 medium test tubes, and a test tube rack. You'll also be using the same test tube rack for the Toland's reagent. For the procedure, measure 10 grams of the sodium carbonate and add it to the 250 milliliter beaker. Then add 100 milliliters of distilled water to the beaker and use a magnetic stir to dissolve the sodium carbonate. While waiting for the carbonate to dissolve, measure 17 grams of sodium citrate and 1.75 grams of copper sulfate, plus or minus 0.1 grams. Pour the citrate and the copper sulfate into the solution and wait for both to dissolve. While you're waiting, prep the supplies for Toland's reagent. Once the reagent is prepared, label your test tubes. Label one sugar 1 and the other sugar 2. Then fill them halfway with Benedict's reagent. Save the rest of the reagent. I'll be collecting it for use in a biology lab. At this point, you should prepare the Toland's reagent, but I'll show you how you'll test the Benedict's solution now. Both of these reagents test for the presence of certain organic molecules called reducing sugars. A positive test shows a reducing sugar, and in this case, that would be dextrose. The other sugar will be sucrose and will not show a positive result. You'll be able to tell me which one is which when you do the lab. Put a sample of sugar 1 into one test tube and a sample of sugar 2 into the other. Heat both of them in the hot water bath for about a minute. A positive test indicating a reducing sugar will have the Benedict's reagent turn brick red. The unused reagent can be given to me, but the used reagent should be poured down the drain. For producing Toland's reagent, you'll need some other materials. You'll need 2 more test tubes, but you can use the same rack. You'll need silver nitrate, you'll need sodium hydroxide, and ammonium hydroxide, which is concentrated ammonia. You'll need to get this from the fume hood, because, as you may have smelled before, ammonia can hurt your nostrils if you breathe it in too deeply. You'll also need a 150 milliliter beaker, a 10 milliliter graduated cylinder, and a 50 milliliter graduated cylinder. For our procedure, you'll measure out 50 milliliters of silver nitrate into a beaker and place it on the stirrer. Weigh 1.2 grams of sodium hydroxide and pour it into the solution. The solution will get kind of gross. Next, measure out 5 milliliters of ammonium hydroxide. Be careful because this will hurt your nose if you breathe it in. Pour the ammonia into the solution and it should clear up quickly. Once clear, the Toland's reagent is ready. Label 2 test tubes as you did with the Benedict's reagent and fill each halfway with Toland's reagent. Pour a sample of sugar 1 into one test tube and sugar 2 into the other test tube. Heat each test tube in the same water that you used for Benedict's reagent. You should be able to time this out to have all the solutions ready at the same time. A positive Toland's test will produce a cool silver mirror effect on the flask upon heating. Unlike Benedict's reagent though, the used Toland's reagent must be disposed of in a special way. I'll have to hit it with some nitric acid. So we will have 2 1-liter beakers set up for disposal. One beaker will be for the used reagent, the other will be for the unused leftover Toland's reagent that you did not pour into the test tubes. Once both reagents are tested, clean up your lab stations and put all of your supplies away.